Welcome to Chapter 8, question number 46. The question reads, a particle moves along a line where the potential energy of its system depends on its position r is graphed in figure 8.46. In the limit as r increases without bound, UR approaches plus 1 joules. A. Identify each equilibrium point for this particle. Identify whether or not each is a point of stable, unstable, or neutral equilibrium. B. The particle will be bound if the total energy of the system is in what range? Now suppose that the energy system has -3 joules. C. The range of the positions where the particle can be found. D. Its maximum kinetic energy. E. The location where it has maximum kinetic energy. And F. The binding energy of the system, that is, the additional energy that it would have to be given in order for the particle to move out to r approaching infinity. Now, for this question, we are given a graph that's going to be displayed here. We are going to be using this graph a lot. Instead of putting the individual clip in there a lot, just refer back to it whenever you have issues. Our givens are potential energy of 1 joule and energy of -3 joules. For A, there's an equilibrium point wherever the graph is horizontal. At r is equal to 1.5, 3.2 millimeters, equilibrium is stable. At 2.3 millimeters, equilibrium is unstable. As r approaches infinity, it approaches a neutral equilibrium, which is obvious if you look at the chart because it gets closer to the x values. For B, energy can't be less than -5.6 joules. Therefore, the particle is bound if E is greater than or equal to -5 or less than 1. C, if E is equal to -3 joules, potential energy must be equal to or less than 3 joules. Therefore, the position is limited to 0.6 millimeters is less than equal to r, which is less than equal to 3.6 millimeters, since that's where that only exists. For D, we know that kinetic plus potential is equal to energy. This is pretty obvious. Now, if you minus kinetic from both sides, you get potential energy. If you minus potential, you get kinetic is equal to energy minus potential minimum. Now, to find K max, all you have to do is substitute. So -3 joules minus -5.6 joules, which will give us our answer of the K max being at r is equal to 1.5 millimeters. PE is least there, which means that the KE must be the highest at this position. For F, -3 joules plus W is equal to 1 joule. If you add 3 joules to both sides, you just get that W is equal to 4 joules. So this means that the binding energy must be equal to 4 joules. Thank you very much for watching the Kirk Academy, and I hope this was very helpful to you.